That's so cool.
Who made Newton's cradle?
Newton's cradle?
Yeah.
Was that invented by Mr. Cradle?
I don't know.
What's on the bottom?
Oh, it's got some wire glued on the bottom. I just need the pie plate.
Oh, nice.
What's going on? Okay, neutral ground.
Leave the pie plate touch. I'll go forever.
You guys are not quite as impressed as you should be with my sweet demonstration.
Leave
Okay,
the pie plates touch.
so if you could describe on like an assessment or something how this whole touching, not touching, grounding thing works, that would be like an expectation I would like you to have.
Okay.
Does that seem reasonable? Okay, and it's all about, right? It's all about rubbing and touching. You donate electrons, and only electrons can move. What happens to the pluses? Nothing. They just stay where they are. Is that okay? How you guys feel about that? Pretty good? All right. So this is really where we ended up on Friday. There are two fundamental properties of matter. There are two fundamental properties of matter. One is called mass. Is that cool? And the other is called charge. Two fundamental properties of matter. What is mass? Do we have any idea what mass is?
Particles and
Sure. I suppose like the mass is related to the amount of particles, right? But what is it though? Where does it come from?
gravity.
What's that?
Gravity.
It comes from gravity?
I don't
And we don't know. There was about 5 years ago now, 6 years ago now, at the Large Hadron Collider, they did an experiment, and they said they found something called the Higgs boson. I don't know anything about this, but they said, oh, the Higgs boson, that's the particle that gives rise to mass. But does that help anybody? I still don't know what it is. But here's the thing I do know about mass. It's related to the number of particles in an object, yes?
Yes.
In physics, it is a measurement of an object's resistance to change in motion. So more mass means harder to get moving, also harder to bring to a stop. True? And the thing that I think is really important is it gives rise to a fundamental force. So last week we talked about this. Right? So this is a force between any two objects with mass. So if two objects have mass, do they attract each other? Yes, they do. Like that is a fundamental force of nature. It's a gravitational force. Is that okay? We measure mass in grams, or in here we measure it in kilograms, yes? In here we measure in kilograms. And we use the letter M. We use the letter M for mass, true? Well, here's the thing. Charge. Charge is the other fundamental property of matter. It is a fundamental property of matter. I don't know where it comes from. I don't know how it got there. Okay? I don't know where it comes from. I don't know how it got there. But we know it's a thing because it has certain properties. So we use the letter Q for charge. We use the letter Q for charge. And we measure it in something called coulombs. We measure it in something called coulombs. If you had a chemistry class, or you currently have a chemistry class, does the word coulomb seem vaguely familiar to you? Oh no!
It finally came down. That took a long time.
Okay. Does that seem vaguely familiar to you from your chemistry class? No? Charge on an object in coulombs? Yes, no, maybe? No?
No.
Okay. So, they knew that charge was a thing well before they knew anything about protons and electrons. So, I mean, think about Benjamin Franklin was doing work with static electricity in the mid-1700s, true? Okay, but they didn't discover electrons and protons until around 1900. Yes? So basically 150 years earlier, there were plenty of scientists working that understood that things had charge. And that there were two charges, right? There were things that were plus charge and minus? Yes or no? Yeah. So, does mass give rise to a fundamental non-contact force of nature? It does, right? Do you think charges give rise to a fundamental non-contact force of nature? They absolutely do. We've seen all the non-contact forcing we've been doing over the last couple of days, yes? Okay, so this is what we're going to do. Okay, this is what we're going to do over the next couple of days. Well, probably just tomorrow. Is you're going to explore, right? All right, now we have to use a simulation because we can't, I mean, it would be challenging to know the actual charge on an object, so we'll have to use a simulation. But what if you had an object that you knew the amount of charge on it? Let's say this object here had like 4 coulombs of charge. Okay? And this, so this is plus 4 coulombs, and this one over here was like minus 3 coulombs of charge. If these were two objects, would they attract each other or repel each other? I think they would attract. Why? Opposites attract, yes? Okay. So if you could measure the force between these two objects, what about this situation could you change that might affect the force? What might you be able to change that might affect the force?
Charge.
Good, the amount of charge. You've made this one from 4 to 8. Do you think the force would be different? It might. So if you change the charge on this one, what about this one? If you change this one from 3 to 6, do you think it might affect the force between them? Okay, and what's the last thing?
Distance.
Yeah, the distance, right? So if you change the charge on either one or the distance between them, do you think it might affect the force? I think so too. So what we're going to do is we're going to find a good simulation that you guys can explore this. Okay? You can explore this and see how it goes. Does that seem reasonable?
Yeah.
I would like, okay, by Wednesday, if you could tell me if you are working alone or within a group to make a mousetrap car. Do you think that's something you can do?
Yeah.
All right, stay in your seats until the bell rings, please. I forgot to take attendance. Oh my gosh.
We're all here.
I'll be here today after school for anyone who needs to reassess.
Mr. Bennett, I'll be there.
I'll be there. I will as well.
I don't think
No problem, man. I just want you to get something out of this, right?
I'm generally just, not my intention to leave.
Okay.
Other stuff going on.
I know. And I'm sympathetic and empathetic.
But I understand it's my fault. I need to focus more.
Well, thing is, I don't like to talk to you guys, but like right now I have to for another reason, so I forgot to stop the video. So anyway,